Good evening, Rancho Verde pre-calculus class. This is Mr. Langston, and today I am doing section 2-1, but first thing we're going to do is our warm-up. So, given f of x is equal to -2 times the quantity of x minus 1 quantity squared plus 2, find the vertex and sketch the graph. So, what we are going to do today, to find the vertex, and I did not mean to move that, so I'm trying to get into writing mode. There we are. To find the vertex. This is already in standard form. So we have the equation f of x equals a x minus h quantity squared plus k. That's an h. It's a terrible h. Let me rewrite it. There. That's an h. Still terrible. So we know that the vertex is going to be hk. And right now, our h is 1, and our k is 2. So we are at 1, 2 for our vertex right there. Now, it's negative, which means it opens down, and it's amplified by a magnitude of 2. So normally on our parabola, we go out 1, and in this case, we'll go down 1. But because it's amplified by 2, we're going to go out 1, down 2. Out 1, down 2. And normally we'd go out 2, down 4. But again, because it's magnified by an amplitude of 2, we'll go out 2, down. In this case, it will be 8. So it's down to -7 right there. And down to -7 right there. So our parabola is going to look something like this. Okay, so for section 2.1, we are doing quadratic functions and models. This is the first section in chapter 2, which is polynomials and rational functions. We are going to do a lot of modeling. Our language objective is that you're going to be able to, using your own words, and it's supposed to be there. And that's why I'm a math teacher, not an English one. Their own words, define a quadratic function. Students will also be able to define a minimum and a maximum of a quadratic function. So let's just jump right down to it. Chapter 2, polynomial and rational functions. We have these, they're already in your pre-made notes. So the quadratic equation, the quadratic function f of x equals ax squared plus bx plus c, where a cannot be equal to 0. The graph of a quadratic function is a parabola. You should know that. Check. Axis of symmetry divides the parabola in half. You should also know that. Check. Vertex of the parabola lies on the axis of symmetry. Check, check, check. And the graph will either open upward or downward. And of course, it's going to open upward, downward if a is less than 0. Sorry, lost my train of thought. And it's going to open upwards if a is greater than 0. So the axis of symmetry of the x-coordinate of the vertex formula is x equals -b over 2a. So let's get right down to it. We want to find the axis of symmetry. So we have x equals -b over 2a. That is our equation for the axis of symmetry. So once we plug that in, first thing we have is b. b is right here. It's -8. So I have -8 over 2 times a. I've got a 1 there in front. So a is, in this case, 1. So what I have is -b over 2a. And when I fill that in, -8 over 2. Well, -8 over 2 is -4, which is 4. So my axis of symmetry is x equals 4. Now, I can also make sure that I have that because this whole thing of f of x is equal to x squared minus 8x plus 16, that's a perfect square. I can just rewrite that as f of x equals x minus 4 quantity squared plus 0. So I have a vertex at 4, 0. I know my axis of symmetry, the vertex lies on the axis of symmetry. And I have my axis of symmetry of x equals 4. That's my axis of symmetry, x equals 4. So I'm in the x direction of 4. So I've got that there. And now if I wanted to, which I do, you can graph it. Right here, the leading coefficient's 1, so it's just going to be a normal type of parabola. So it's going to be out 1, up 1, out 1, up 1, out 2 to the right, up 4, out 2 to the left, up 4. And the reason it's called an axis of symmetry is because it's symmetrical. And what I mean by that is, imagine this parabola was written on a piece of paper. And if I folded the piece of paper like I fold a paper airplane, the parabola this side would overlap this side. It would like be perfect overlapping of each other. So that's why it's called the axis of symmetry. You know that fold on a paper airplane when you do that very last fold over and how the left and the right just comes together? Well, it's because those two sides are symmetrical. It's the axis, in this case, the fold is the axis that makes the two sides symmetrical. So let's actually go to this one. We have to sketch the graph of f of x is equal to negative x squared plus 6x minus 8. I don't want to do that one yet. What I want to do is actually an easier problem. This is actually in your notes, this one. And before you get into that one, I want to get into an easier type of problem. We're going to take this one. Now, this problem involves what's called completing the square. And what you are going to do is, first thing, is you're going to take that negative 3 and you're going to separate it out. So what I'm going to do right here is I'm going to say, and I'm not going to rewrite the f of x, I'm just going to put the equals. So I'm going to put the first two terms, x squared plus 4x, I'm going to put them in parentheses. So I'm separating out the first two terms and the last term. So I've got the first two all together, and I've got my last term minus 3 here. Now, what I'm going to do is, it's called completing the squared. So I have x squared plus 4x, and I'm going to say plus a number, but I'm going to subtract that same exact number. And the reason I'm going to do that is if I add a number, I'm changing the equation. So what I do is I add and I take away. So the equation itself is balanced. I'm just adding something. It's like me putting in a pinch of salt and then me taking that pinch of salt out. So I'm just adding something and taking it right away. And that way I'm not really changing the equation, but I am going to do what's called completing the square. So to complete the square, you take the middle number. So in this case, I take 4. And you divide it by 2, and then square the whole result. So I have 4 divided by 2, quantity squared. And that is going to become the number that I put in here. So 4 divided by 2, that's going to be 2, and then when I square it, I get 4 again. And that's the number that I put in. So I say plus 4 minus 4. Now, once I do that, I'm going to take this minus number here. This minus number. And I'm now going to pull it outside the parentheses. Now, for me to pull it outside the parentheses, if there was a number in front of this parentheses, this number that I pull out is going to get affected by that number as I pull it out. In this case, I've got nothing in front here, so I'm going to be completely okay. just to have the minus 4. So what I have is this now. I have f of x, and remember, I'm not writing the f of x part. That's equal to x squared plus 4x plus 4. And then I have minus 3. And now I have the number that I pulled out, minus 4. So minus 3 minus 4, you should be able to figure what that is, and I'll put it in a moment. But let's just focus right here, okay, at this parentheses. What I'm going to do now is take the square root of the last term, and I'm going to take the sign of the middle term. That becomes my new perfect square. So I have x plus, because I take the sign, square root of 4 is 2. And I can make that into a quantity squared. And then I have this that I've got to do, minus 3 minus 4. So in this case, minus 7. Now, the reason that this trinomial can become this binomial squared is because, let me just square it out, and you'll see it. So I have x plus 2 times x plus 2. I'm going to take this and square it out. So 2 times 2 is 4, 2 times x is 2x, placeholder. X times 2 is 2x, and x times x is x squared. And now when I add it all together, x squared plus 4x plus 4. So x plus 2 quantity squared is x squared plus 4x plus 4. So all I did is I just completed the square. And now it's in standard form. So I can put my f of x right here, and everything's good. So, yay! And by the way, its vertex is going to be -2, -7. So let's go back to here. We're going to complete the square on this. This is a little bit more complicated because I have a negative right there. So what I have is f of x is equal to, for some reason I just like rewriting everything. It's a thing. I don't understand it myself. I don't pretend to. So negative x squared plus 6x minus 8. So I'm going to do exactly what I did on the last one. So I'm going to do f of x equals, and I'm going to put the first two in parentheses. So negative x squared plus 6x minus 8. Now, for this one, the one different thing I'm going to do is I need my coefficient in front of the x squared to be 1. So I'm going to pull out the negative. Now, when I pull out the negative, the signs of everything on the inside here changes. So what I'm talking about is f of x is equal to negative, in this case, x squared minus 6x minus 8. So this became a positive term, this became a negative term. And I still have my minus 8 out here. Now I'm going to do the spaces to complete the square. So f of x is equal to negative x squared minus 6x plus blank minus blank minus 8. And again, I take my middle term. So I have negative 6. And I'm going to write that in black, my negative 6. Now in red, divide it by 2 and square it. And that becomes the new numbers here. So negative 6 divided by 2 is 3. 3 squared, 9, and 9. Now, this is okay. I'm doing great. I need to take this 9 and I need to pull it out. So when I take this negative 9 here, and I pull it out, I've got to remember, though, that this negative 9 is being affected by this negative in front here. So minus a minus 9. So I have f of x is equal to negative, in this case, x squared minus 6x plus 9. And I have minus 8. Now, I'm going to pull this minus here. Minus, because remember, it's affecting this, minus negative 9. And in this case, when there's two negative signs, minus a minus is a plus. So I have now f of x is equal to, remember now that I square root the last number and I take the sign of the middle number. So I have negative x minus, the sign's negative in the middle, 3, because the square root of 9 is 3. Quantity squared, minus 8 plus 9, that becomes plus 1. So in this case, my vertex is 3, 1. So I can go 3, 1. It opens down, and its amplification is just 1. It's not even being amplified. So it opens down. So I have, and out 3, down 9. Right there. So it's not easy graphing on using an inner-right pad. And there you go. Now, last thing we have is writing the equation of a parabola. So you need to write the standard form or the vertex form of the equation of a parabola whose vertex is 1, 2, and that passes through the point 3, negative 6. So I already know my vertex form is f of x is equal to a x minus h quantity squared plus k. My vertex is here. Here's my h, it's 1. Here's my k, it's 2. So I have f of x is equal to a x minus 1 quantity squared plus 2. Now, I don't know what my a is, and that's why I'm given this point here. I'm going to take and substitute x is 3 and y is negative 6. So I remember f of x is your y. So I have negative 6 is equal to a 3 minus 1 quantity squared plus 2. So 3 minus 1, that's going to be 2. So I've got negative 6 equals a times 2 squared plus 2. Or negative 6 is equal to 4a plus 2. So if I minus 2 on both sides, I get negative 8 equals 4a. So a is equal to, in this case, negative 2. So my equation now is f of x is equal to negative 2 x minus 1 quantity squared plus 2. So I'm now at 1, 2, that's my vertex. It's negative, so it opens down. And I have an amplification of 2. So it's out 1, down 2. Out 1, down 2. Out 2, down, in this case, I go down 8. So it'll be right there. And right there. So this is what my graph looks like. All right. So that's all I have for you today. Again, this is section 2.1, beginning of chapter 2. Yay. If you have any questions, feel free. You can ask me in class or you can email me. All right, class. So that's it. I shall see you guys later on the flip side. Good luck on your homework and peace.